I'm Rebecca Brenton. I'm Partner Alliances Manager for Cloud Solutions Group at Dell. I'm here with Rob Hirschfield, and he is our Principal Solution Architect. Reason we're here today, we want to talk to you guys about our Crowbar deployment tool that we developed for OpenStack. We're also using it with Hadoop. But that is our point, what we wanted to share with you today. I wanted to share a little bit of backstory of how we got to Crowbar. And then I'll be handing it over to Rob, and he's going to show you a demo so that you can see the tool in action. So I'm sure most of us know what OpenStack is, but in case folks don't, wanted to have a little bit of information up here about OpenStack. So it's a cloud operating system. It is community developed, open source. And my real point on this slide is Dell's involvement in this community. Dell has been a supporter of OpenStack since day one. We have been behind this. And I know you might be thinking, Dell, hardware company, why would you be in software? We're a Cloud Solutions Group. We are very much about software. We certainly know hardware is important, but it's software and the capabilities of that software that really drive our market and drive use cases and what people are doing with software. So as I said, Dell has been involved with the OpenStack community since day one. We were there. We have been a part of this. We were the first to offer a solution on OpenStack, a combined offer of the hardware, the software, as well as services and support, which, as we all know, is really important for any open source code. And we also developed Crowbar, which again is our point here today. So OpenStack, again, if you don't know, it does deliver everything that you need from a software perspective to stand up your own private cloud in your environment. So what Dell did with this, we knew that the OS was going to be a very good thing for our future, for our community, but we also knew that that in itself wasn't something that you could really install in your environment. There's a lot of work that you need to do to fine-tune something like that and be certain that it fits. So what we did, we took that open source code, brought it into our labs, and developed a reference architecture that we tested and validated, that it was assembled in a way that was going to deliver the most efficient delivery of your OS for that. We have the deployment guide. We figured out, the servers that you'll need, the switching that you will need. We put all of these pieces together. But as we were doing that, putting all these pieces together, we figured out, wow, this is hard. There's a lot of work that needs to be done just to get the bare metal up and ready to receive OpenStack so that you could stand up your cloud. And out of doing that work in the reference architecture is when we built the software code for Crowbar. So we built it for our own use because it was taking weeks to get the bare metal up. And once we put it all together, we did the earth-shaking move in Dell, which was a fun thing, and said, hey, we're going to open source this software to the community so others can contribute to it, so that it can expand, and it can help the greater good. That blew a lot of minds, but we also had a lot of fun with that in getting that solution out there. So that's how Crowbar was actually born, was to help us get our offer out to market. So again, our reference architecture contains everything that you're going to need in order to deploy your own private cloud, but the reference architecture is also it's flexible. It's not prescriptive. You're not stuck in one piece. You can change it to work in any way that you want. Our reference architecture also includes ISV partners that we are bringing on board, which is close to my heart, of course, because OpenStack in itself is good, but it needs more components on top of it to really make it something that you can use within the enterprise. So, for example, one of our first partners in Stratus brings in a billing solution. And then we said, well, if we're going to bring in Stratus, again, we need this way to port them into the solution. That's where Crowbar came to the rescue once again. And we have essentially a connector that we call bar clamps that allows these partner solutions to then be plugged in to the OpenStack solution. And that's where, we've got Crowbar. So fully automated tool to allow you to stand up OpenStack, and it does work on Hadoop as well. And Rob's going to show you guys more of the details around it, but I did want to make sure everyone knew that it is chef-based, and it is 99.9% open source. There are some BIOS and some RAID settings from bare metal. Dell doesn't own, so we could not open source that small percentage of what Crowbar has. But if you know Chef, you know Crowbar. And with Crowbar, you can actually stand up a private cloud in your environment within hours, rather than days or weeks. And we really feel that that's an awesome thing to bring out to the community. So we're quite proud of that. So just to wrap up, because I'm sure all of you would like to actually see what we have, just want everyone to know that we definitely wanted something that was going to be simple for people to use. It also had to be something that was optimized for your environment, had to be something that was worth your investment. So by building our reference architecture, by having the support and the services, by collaboration with partners to bring in added functionality, that's where we've got the complete offer for you. And if you know Chef, you know Crowbar, which means you know OpenStack. And it delivers what you need. So with that piece, I want to get it over to you, Mr. Hirschfeld. And we've got your taxonomy up first.
So if you are tweeting, hashtag, right, ChefConf, if you throw in OpenStack, and you want to use back channel for questions or things like that, please do.
Oh, and before you get going, Rob,
sure.
I did bring in a few T-shirts, so first 3 questions Rob likes. You get a Dell T-shirt.
What size
Robert's
T-shirt is
like
such a question?
I don't like it.
You don't like it?
Tough, hard questions. All right, so I'm going to show you some really cool stuff. This is a live demo. And so I'll give you a little bit of setup because I want the live demo to run in the background so we don't have too much Crowbar time. So what's going on here, we have a PowerPoint presentation. This is our, what I call 2-cloud taxonomy for OpenStack. And so what it's showing here is it's actually showing a full ops infrastructure. So if you're doing the ops side of OpenStack, you care about bare metal, operating systems, operational services that are necessary to actually deploy OpenStack, the OpenStack suite of components. OpenStack's only a piece. You guys know this. You're all ops, DevOps people. It's only a piece of what you need to be successful. And then on top of that, you can actually then leverage the APIs and use OpenStack as a cloud infrastructure on top of it. You have to have both pieces to be successful for what we do, which is private cloud, helping people bring up their own. And that in some cases that some people are telcos, hosters, people with very large-scale clouds, some people with smaller clouds. But then you can actually use tools on top of it, like Chef. So let me show you what we're doing. I'm going to jump over to the actual demo. In this case, what I have is this is VMware Workstation. I've already deployed a 3-node cloud. I'm going to boost it as if I brought in a physical server, racked it, wired it into my switch, and booted it for the first time. And I'm going to start this process just because it takes a little bit of time. And I want to be able to show you some of the background. So we're going to effectively take an existing OpenStack cloud, got a 3-node cloud deployed, and we're going to bring in 2 new servers to triple our capacity for compute. Okay. And the way this is going to operate is just as if you plugged in a server for the first time, it's going to pixie boot. Crowbar infrastructure is going to come in and put in a dissolvable operating system to make this stuff, make it work. But let me show you what we've got. Let's keep going down here. So the challenge that we had in building this up was that in order to build the OpenStack pieces, right, where the money is for what you want to do, where right, we want Chef to be able to control the OpenStack cloud and actually deploy applications on OpenStack, we had to bring up all of this infrastructure. We had to make sure all those pieces were working. So we had 2 challenges. We had to both build this OpenStack cloud, and then we had to be able to deploy pieces on top of it. So that meant we have to build this full cloud infrastructure, right? You can't, this is crazy, but you can't bring up a cloud without NTP. Time synchronization isn't there. You can't actually use anything. The whole thing fails. So even little pieces like NTP, DNS, Nagios for monitoring, Ganglia for doing performance tuning. All those pieces were important. And for us, it was really significant that we did it multi-node from the start. Okay? And there's a lot of pieces around that and what we're talking about, but we didn't want to just stop there, right? Dropping OpenStack on somebody's doorstep is great, but it doesn't help you make money, right? Make your company run. It doesn't help you get applications deployed if that's what your target is. So what we want to be able to do, and this is what this demo is focused on, because I have plenty of demos that I can show you deploying OpenStack. We do that every day of the week, 3 times a day. But what this is the first time we can really show this end-to-end, where we're actually using Chef, the same Chef server that Crowbar deploys, because Crowbar is based on Chef. We're going to use the same Chef server that runs our OpenStack cloud and did all the deployment and built all the infrastructure. We're going to actually use that then to control the OpenStack cloud that we've deployed in that infrastructure. So Rebecca's already talked about Crowbar. I won't reinforce too much more about this, except one point that's really important. Crowbar is an open source project. It is not a Dell-specific project. Okay? So anybody with any gear can download this project, use it, deploy it, get things running. It's not only OpenStack. We actually just yesterday launched our next iteration of our Hadoop Cloudera-based solution into this. We have other components that use it. It runs on multiple operating systems. It's a pretty deep solution from that perspective. And since it's based on Chef, cookbooks are the primary mover for bringing up components. Okay. And we've been doing this for a long time. We've actually been in, and I'll talk about OpenStack at the end. This is what happens. So I'm showing you the Pixie boot system. We boot physical resources. So switches, right? We had servers come up. They get Pixie booted. They get discovered. You actually get put into a hold state until you know what you want to do with them, and I'll show that a little bit. And then it deploys the operating system and actually integrates into operational capabilities so that, right, we believe very strongly that just booting a server, throwing an image on it, is not sufficient, right? This is operational infrastructure. You need to be able to operate it. Deploys an application on top of it. Our solutions deploy OpenStack and Hadoop. We have people in the community who are deploying other applications. And then you can bring in API consumers on top of that, right? And Stratus is a sponsor of the conference and a partner of ours. They have a management orchestration system on top of these APIs that allow you to have much, very easy to use billing capabilities. And I'm on automatic advance, apparently. Wow.
Talk fast.
Yep. I'm working on my Ignite deck. Apparently, I cut and pasted a little bit wrong. So and then, of course, Opscode. And the thing that's really exciting about Opscode is that when you look at how this is an architectural drawing of what we do, where we build up these same 4 layers, these same layers of the system, using Chef Client at every step. We actually use Chef Client to do our BIOS, OHI to do our discovery. All that runs around the Chef server. We had to add orchestration on top of that to control the state transitions, right? You're bringing up a large-scale multi-node system. You have to do it in sequence. And then we also use Pixie and DHCP discovery, right? And the open source version will still do things like network discovery, Pixie boot, set up BMC, IPMI. There's a tremendous amount. We've worked aggressively to put everything we possibly can into the open. And the thing I'm most proud of is we do our work in the open. So you can actually go and watch our commits, see the work that's doing, interact with things, push requests in. We actually have a license agreement. We have partners who are coming in with this. There's a major operating system vendor whose pushes are about to come in and expand our support. So there's a lot of activity. It's a really exciting project for that. Right. And one of the things that we do in this, and if you're doing Chef, I don't know how many of you are using the Chef server. If you want Chef inside, one of the advantages that we have is even if you do nothing else with it, we deploy the open source Chef server as a local server. So you can do local management using Chef and actually take your operations infrastructure internal and to the next level. Right? That's part of what we're trying to do with this. And then I'll show you. I'll do this. What I haven't shown you at all yet is this is the Crowbar UI. This is the open source version. Projecting of the Crowbar UI, and what we've actually done here make it more visible is we've actually deployed. These are the 3 nodes I've already deployed. These are the 2 nodes I just booted. They're in an allocated state. They're waiting for instructions on what to do. I'm going to skip forward a little bit. So in this system, we have a view of the nodes. We actually collect all the OHI data. Chef is our database. This product has no external database, so we actually store all the data in Chef. So when you write a cookbook, the data that we're using to make decisions about orchestration is data that you can use to make decisions. So this is only a tiny bit of the OHI. There's megabytes of data of OHI data that we collect for the system. But you can actually see we bring in the roles and things like that. There's also pretty sophisticated switching. We visualize the networking infrastructure. This is all virtual, so I have 4 networks. And we actually visualize the VLAN infrastructure that we're going to set up, which is pretty cool. And then this is the concept. Our bar clamps are basically cookbooks, but with components around them that help them be deployed internal infrastructure. So all the RPMs or gems and devs that you need to make your application successful without an internet connection. You can take the Crowbar ISOs and deploy the entire infrastructure with no internet connection, which you would be surprised even in an internet data center is often the case when you're provisioning new gear. So the system comes up in a consistent way with no external connections at all. And what we've done is these actually match back to cookbooks. So to deploy OpenStack, I've had to make a whole bunch of infrastructure layers to bring my system up, right? I've needed MySQL, Keystone is the authentication, Glance is an image cache, Nova dashboard is the UI for OpenStack, I'll show that in a second. Nova is the actual compute infrastructure. So to get all the way to the point where I could use this cloud, to layer in a whole bunch of different components, right? If I want to bring in more components, I can add those into the system. What I'm going to do is crack open my Nova deployment, and in this case what we've done is, you guys are chef guys, you can handle JSON. We've actually put a little bit of UI in front of what's inside of your data bag. Right? It's a JSON file, here's all the parameters that are necessary to drive the cookbooks. You can modify them. If I chose to change them around, I could. In this case, I use QEMU because I'm running virtual and virtual. And then down here, this is effectively my run list. So Crowbar is going to manage my run list for me to determine what roles are being set up. And I can take these 2 new nodes and I can build them. Let's do it here. I can drop them into this system. Now remember, these guys are just booted into discovery mode. They're waiting for instructions. They don't have an OS or anything. I can come back here and hit apply. And when I do that, Crowbar is going to go back to these nodes which were spinning in this idle state. It's going to identify what needs to be done. In the Dell version, it's actually going to update the RAID and BIOS based on the needs of that application. Right? If it's Nova, it turns on the virtualization bit. It formats the drives in array 10. If it's storage, which is a JBOD configuration for OpenStack and Hadoop, it doesn't turn. It sets up the RAID, the BIOS in a way that's optimized for that. It sets up the operating systems using JBOD, right? So it takes care of all that stuff. It's going to go through and it's going to deploy the operating systems. Come back to that. It's like a cooking show. That's the balance of getting the right stuff in the oven. Exactly. So the thing that's really interesting here is that this Chef server is running local in my environment. So this is that local Chef server I was telling you about. And you can see I've already got, let me hit refresh so you get the nodes. First, these are the node names come in based on their MAC address, but we alias them so that they're more friendly, and then put that alias in the DNS. This is how the integration works, right? You add an alias in Crowbar, it actually tells the DNS, which there's a bar clamp for the DNS. We actually inject that back into the DNS server so you can then use the alias names when you make requests in the DNS, or in Knife, we can actually do that, groups, a whole bunch of cool add-ons that we can put in there. So in here, you'll see we have the cookbooks. So down here, here's Nova Dashboard, here's Nova, these are all the OpenStack pieces that were necessary to bring up the system. And of course, all the roles that go with it. What Crowbar has done is it's really automated a disciplined approach to using Chef. Right? In order to make these programmable, we're using roles in a very consistent way. We're separating concerns of cookbooks. We actually have a wall where cookbooks can communicate with each other and actually pass information. Oh, I set this up. Oh, I did this. Same thing is true with networks, right? When I set this system up, it doesn't build any networks. As I need a network or a VLAN, we actually tell the node how to build those networks for that system. Networking, especially like Hadoop or OpenStack, requires a lot of specific VLANs on specific nodes to specific places for specific apps. We actually have a networking bar client that builds all those things up for you and then rationalizes it. This is way beyond the topic, but we have some really interesting stuff where we actually take the networking and we normalize networking. So even if you have 6 different types of gear, you can consistently say, I want this Ethernet card and port on this server to be this thing consistently, which if you guys have brought out physical gear, it's a huge nightmare. Right? The same gear actually has different NIC enumerations in Linux. Yeah. So it's still bringing things up in the background. It's actually flashing to tell me it's waiting. So the proposal, so we have a proposal system where you make a recommendation, you request a set of resources, it queues it. In this case, it's actually building. Crowbar made the decision, you're asking for nodes that aren't ready yet. So I have to install an operating system and install Chef Client and do all the prep work. So it's actually queued this proposal, waiting while it builds the operating systems and gets everything ready. But because I've already deployed OpenStack, I can log in with OpenStack. Let me hold on for a second and show you something before I get there. All right, this SSH session is just a machine. It's a VM running on my desktop. It has access to my Knife server. I'll show you everything. So I already created this OpenStack client. And so if I do a Knife node list, this node list is going to show me the node list of the Crowbar servers in Chef, right? That's what Chef's managing. This is my node list. Okay. If I turn around and say Knife OpenStack, using Matt Ray's OpenStack plugins, right, which is then based on Fog, I can come in and I can say I want the flavor list. I'll show you what a flavor list is in a second. All right. I'm going to pause for a second because this is super cool. I just used the same friggin' tool to inspect my physical infrastructure, and then I turned around and used that same tool to inspect my virtual infrastructure. Okay. So in this case, I'm actually doing a list. I can see what my flavors are. The flavors are the Amazon. They map to the Amazon sizes in AC2. I can do the same thing. Instead of flavors, I can get my image list. Image lists are going to use GUIDs for identifiers. Let me show you what OpenStack looks like. So here's the OpenStack UI. We're using Ubuntu 12.04. Crowbar deploys the Ubuntu packages for OpenStack. So that's why it's branded with Ubuntu on it. And this is my admin dashboard with all the pieces and parts. And so we create some users by default. Our goal, and I have a whole bunch of slides I'm not sticking to, it was to get people up and running with OpenStack really fast and then give you the flexibility to do whatever you wanted afterwards. So what I can do here, what I actually need to do is I need to import my key pair, which is right here. So I've imported my key pair, and then the other thing that you need to do for this is we actually need to get a public IP. I don't actually have to make some of this stuff work, but since I'm trying to show you how to use this, it is important to note that there's floating IP assignments in OpenStack. You must request a floating IP if you want that system to be externally addressable. And I will tell you, because of the way the networking works, it actually matters which NIC and outbound networks you are on when you get these floating IPs. Public and private networks are split. And part of the whole thing that we've done with this is we've made it out of the box very straightforward, but at the same time incredibly configurable. right? You can totally manage with your networking however you want it to be with Crowbar, right? Because we have huge battle scars, broken legs, and head sprains from dealing with customers' networking configurations when we show up at their site. Nobody has the same. Nobody knows in advance necessarily what they're going to have. Right? So we had to build a tool that when we showed up on site and somebody said, ha, you know, I told you that we were going to use VLAN 500 on this interface. Well, no, we're actually going to use VLAN 600 on this other interface, and you guys have to be done by this afternoon. Thank you. Right? That's perfectly normal. You've got to deal with it. This is snowflakes that Adam was talking about. Right? That's why we use Chef in the middle of this tool. So we've allocated the address. So what I want to do is I want to come back in here, and I want to do a knife OpenStack. I don't know all the commands by heart, so I'm going to do server create. It's going to tell me. Tells me it's not. I'll. Somebody wants to look it up while I'm struggling with remembering all my command line additions. Then we'll come back to it. I'll jump back to the slides for a second.
You get a T-shirt for the right answer. You'll like
Excellent. I do like that. So let me jump back to my slide deck, see if I'm at least on track somewhere. So I'm actually walking through this. This is what we're doing, right? I showed you the importing the key, requesting an IP address. I didn't build the server on this. I'm trying to do it in Chef. Chef side of it, right? I talked about Matt Ray, lots of server variants, listing flavors, listing images. This is where in my rush didn't copy in my parameters. And so what I'm trying to drive towards is installing, right? We already did the Crowbar Chef server. We brought up the multi-node. I started with this, okay? And then we're doing the OpenStack pieces. Oh, I want to show you the extra servers coming online. UI for management, and then using Knife with pieces. Okay. Oh, I'm coming back to show you over here. So back in my dashboard, it's going to show all these are green, and the OpenStack bar is all green. There used to be a screen in OpenStack that would show me my total capacity. They took it out. I need to put it back in. Just because I could actually show you that I've now added all this extra RAM into the system and made it go. Okay. Nope, I don't have it. I'm still waiting on somebody.
So just have to change the server create, not create server.
So what you'll actually see in all this stuff is this initial block is what I needed to access the Crowbar system, which I'm very used to doing all the time, and then the OpenStack pieces, foo is not actually passed in, but you can just pass in your username, password. You need your tenant, which is in
Capital S.
Is dash capital S?
Yeah.
Let's see it. Oh, okay.
All right.
T-shirt.
Yeah, there's
Should be about
t-shirt.
17 T-shirts.
Yeah, I think you're right, right?
We each take a piece.
So let's see.
I want sleeves, man.
So this guy is going to come back and
No. It's fun.
So was that because Knife doesn't provide context?
laundry.
it's still probably an error.
Excuse me,
Yep.
was that a failure of the plugin to provide the context-specific help, or was that?
Yes.
Is that okay?
Yeah. So this is very new in the sense that Matt and I won't throw Matt under the bus because we were both collaborating on this. I'll take the heat. But this is the Essex. So this is one of the challenges. Actually, this ties into where I am in the prezo, anyway, which is OpenStack. So this is the roadmap for Essex for OpenStack. So one of the challenges with OpenStack is that there are actually a lot of flavors for OpenStack, right? HP, rack space. We try and do entirely default, but even for us, one of the bugs that we encountered in trying to get this demo ready was that Fog didn't account for public and private IP addresses in the way it returned lists. So that's one of the things that we were working on, and so one of the challenges with OpenStack, and one of the things that is really important to me and what we're doing with Crowbar, is that OpenStack has a lot of variance, right? Because it's this emerging project and people are deploying it different ways in different parts of the life cycle. What we have done with Crowbar by open sourcing all of the bar clamps and the cookbooks that we use is we're encouraging the community to collaborate around getting this operationally done, right? Actually, on the May 31st, we're having a worldwide deploy day where we're taking Crowbar, we're going to invite our partners and customers and interested people in the community to work with us on deployments and test it in their environments, in their setups with Knife and with RightScale and Stratus and the Unix distributions that we work with, which are multiple, getting all those things going, because when you use it, right, we want to make sure it's consistent, right? And we're driving towards that. This is part of what Dell's role is in this project, right? This is it's a role we chose from day one, right? Rebecca was saying we started doing OpenStack from the first day. When we started, we said, this stuff is complicated, right? The infrastructure that you have to deploy has a lot of moving parts. It's a lot of pieces, it's a lot of components, there's a lot of, all the yellow arrows are separate APIs for the infrastructure. And somebody needs to step forward to make it deployable in a repeatable reference fashion. And that's what we're doing, right? We want to make sure that if every single person comes in and sets up OpenStack and then uses the tools against OpenStack, that there is a very high probability that yours will work with somebody else's and the same tool chain that you're using will operate in both. So we are out, and the reason why I was doing the dev work with Matt and the reason why we're collaborating on this stuff is because we want to make sure that Knife OpenStack works against Knife OpenStack, right, against OpenStack. And the only way to do that is to work in an open source project where a lot of different people can download the tool, deploy it in their own data center, see what's happening, and say, hey, it didn't work for me for this because you forgot this configuration option, right? It sounds like a lot, but that's what we're doing. That's what we have, a community of people working with us with Crowbar and OpenStack to get done, because that is where everybody in this room will be able to leverage this type of technology, right? It'll accelerate you, it'll reduce your error rates. Really, it's a significant story for that. Does that make sense? I'm on my, this is, obviously I'm very passionate about what we're doing because this type of technology solves a lot of people's problems. Splintering it and fragmenting it does not solve anybody's problems. So we're trying to help it converge, and we've taken on the role doing that. Let me jump back 2 slides. For those of you who don't know it, how many people know a lot about OpenStack? Are really comfortable with it? All right, I've been flying through what OpenStack is, and I apologize. So hopefully you come away with, you at least have the impression, oh wow, this is really interesting, I just wish I knew what it did.
It's Amazon in the box. Yeah, EC2. Amazon and GitHub.
Yes. So the purpose of OpenStack is to be able to create an open API-based cloud, programmable infrastructure like what Amazon offers, but in your own data center, and also have the same API across multiple vendors' infrastructure. So you can use Knife like I'm doing to do physical and virtual infrastructure. You can actually do Cloud A, Cloud B, Cloud C, and your own cloud, one infrastructure solution, right? And that way you have choice about which infrastructure you use, right? They'll still differentiate based on performance and price and service and all the great things that you want differentiation on. They won't differentiate based on API, because none of us benefit, right, from having API be the differentiation factor, right? We want that to be better. So here's what's been going on. OpenStack is a very young project. I want to watch my time. Ooh, good. OpenStack is a very young project. Relatively speaking, there are very few open source projects like this. Crowbar tries to emulate OpenStack by taking community input and active development and doing everything in the open. But, oh my God, the number of companies, the number of moneyed companies, and normally competitive companies that are actually jumping in together to write code as something where everybody's coming together is impressive. Every major name, except for maybe a major hypervisor vendor and large software vendors, is is in this mix. And so what we've seen is we've seen a maturity of the system coming up to the old release. The last release was Diablo. The current release is Essex. One of the things that is amazing about this community is this community chose in Essex to stay away from bright and shiny objects to a large extent and focus on deployability operations. Right, I was at the OpenStack Summit 2 weeks ago, and there is a significant volume of discussion, and I'm proud to say that Dell's helping drive this because we've made deployability a major topic from day one. There's a major thread of people showing up to talk about how you deploy and operate this cloud infrastructure, right? And so there's a lot of emphasis on stable, on making sure that things are working. There's still pieces that we need to get, and so when we look at the next release, which is Folsom, it's alphabetical progression, you're going to see some very exciting innovations now that the platform is rock solid stable. And those innovations are going to be around networking, programmable networking. So software-defined networking is a really interesting thing that's coming. And then block storage, where you can really follow the more traditional, I use blocks, you want to use block storage and back your VMs with block storage. Those pieces will work in certain configurations, but we want to make them more programmable so that you can create APIs that actually, you write Chef that really does amazing things configuring networks and configuring storage to back your applications and servers. Right? And we're following the same trends, but doing it in physical infrastructure, where we're making networking more programmable. We're making your bring up of physical infrastructure much more. It's Chef. You can code your operations all the way down to the physical levels. So I talked about this. It's actually interesting to note Microsoft is the operating system. The company I was not talking about Microsoft. They actually are trying to come back into the OpenStack approach. There's a whole bunch of interesting stuff in here. The top two projects that people track for OpenStack, the bright and shiny things in OpenStack, is a project called Quantum, which is tied into OpenFlow and Open vSwitch, and then Cinder, which is the new name for the block storage API systems. If you care about the operational infrastructure, which everybody here does, it's a great project to get involved in. And with that, I'm actually just about out of time. But I have one or two questions.
When you're booting at the initial Pixie stage, you have the information indexed to the node?
Yes.
And how do you do that?
It'll use the MAC address of the request.
Yes.
So once we actually create a node in Chef, at the time we own the Pixie server.
Yep.
So actually we own the DHCP server and everything. But so yeah, when you get the DHCP request, it actually identifies it and brings up the node, registers it in Chef, and then starts the whole process.
Do you do anything beyond the information in the Pixie request, like boot a kernel, do an high run, and save that back?
Yes, we do. There's a dissolvable in-memory image that gets booted as part of that whole process. So when a node is being discovered, it's called Sledgehammer. Yes, we like our tool analogies. And so it actually boots a discoverable image. It does a full high run on that system. And one of the things that's awesome is not only did we extended OHI and added LLDP, which is a network discovery protocol, and we actually collect the switch information, which is why I can visualize the switch. And actually, so the virtual stuff doesn't show you anything. It's use more colorful language, but it doesn't show you anything. And so what we do on actual physical gear is I know exactly which ports on which switches you're hooked to, and as you hover over a port, it shows you the other ports that same node is attached. It's super sweet. I love that UI. It's great. I wrote it, so it's easy for me to like it.
So one of the things,
T-shirt?
maybe a fun one. I've had a 1.2 / Diablo running for a while. And so it's kind of stuck on a 1.2 Diablo. 1.3 is supposed to have upgradable. How stable is that? Last deploy day, it was
so
kind of floating around.
I'm thinking you like his question.
I did like the question. So Essex right now is very stable.
Stop by our booth.
Essex, our Essex stuff out there is very stable. It was more stable on Sunday night than
Oh
it
yeah, I'm
is
familiar with
Tuesday.
where it's
Because,
It's
well, we had a whole,
very
we just finished a release, so we
Mhm.
have a whole month of code that we didn't check into the trunk. We're bringing in some interesting features. Luckily, I built an ISO at that point, but
But the bar clamp
that'll
upgrade
stabilize.
stuff
The
is
bar
the-
clamp
the
import
the core bar clamp
is there.
Okay.
It's not as much of an upgrade strategy as it is a way to get new code,
Right.
which is different.
Well, if you jump, at least I can follow the current builds.
You can bring in the new
Right.
pieces. Although there was a whole bunch of stabilization that we did over the last couple weeks, and
Excellent.
you would benefit from that if you rebuild and stuff. Upgrade itself is a major feature that we are working towards so that you can actually, so part of we've committed to deployment, we've been working on that, I've shown you a lot of great stuff. The next thing for us to extend that is upgradability so that we can do continuous deployments of physical infrastructure, which is like Nirvana,
Yeah.
and we're working towards that. That's important to us.
So recently, there's, I think about 30 days ago, there's been some code committed to OpenStack's trunk relating to bare metal installation
Mhm.
under the whole OpenStack ecosystem. Have
Yeah.
you guys gotten any involvement in that? or-
We do have some involvement in it. The use cases are a little bit different than what our core focus is because they're trying to treat physical machines like virtual machines. And so, they're related, and at some point we're going to try and bring them together because of what we're doing, and we're tracking it. It's an interesting. Some of the use cases on that are a little funky.
It's new.
It's
People have developed their own stuff for their own specific needs, and they're trying to make it.
and we are trying to keep very generic, right? That is our goal, is to have a tool, because the thing that's important, I've talked about OpenStack here, because it's, to me, this idea of being able to use Knife to do both physical and virtual is huge. But we deploy Hadoop with this. We just did our Hadoop release, which is a very big deal. It's very hard to deploy Hadoop. We've made that easy, and we don't want to compromise the flexibility. And I think we're about to get kicked out of the room. If you have more questions, please come by the booth. And do I have a last slide? Oh. And of course, Dell.com, OpenStack, Dell.com, Crowbar. That will take you to the GitHub sites, community lists, and we have all sorts of resources available.
Slides available later?
I will upload them. I'll post them here.